but I'll tell you what to write specifically. That would be fine. Okay. So this is going to involve trig identities, and then using trig identities to verify statements. Okay. So this little worksheet was intended to help you understand where the trig identities come from. Okay. So usually you're just kind of given these identities, and you kind of just say, okay, well, I guess these work. Somebody proved them at some point. Well, I'm going to show you that they are in fact true. Okay, so everybody knows that sine is the y, right? The opposite over the hypotenuse in this case. Cosecant is its reciprocal, so what's the reciprocal of y? 1 over y. Okay, so cosine is the adjacent over the hypotenuse, so in this scenario would be the x. And secant is the reciprocal of cosine, so 1 over x. The tangent is opposite over adjacent, so that would be y over x. And the cotangent is the reciprocal of that, which is x over y. Everybody okay with where those pieces are coming from? Using this fancy little triangle here? Okay, so if we use Pythagorean's theorem using this triangle, what would we have? Pythagorean's theorem? X squared plus y squared equals 1 squared. Okay, yeah, so yeah, absolutely. You could just say that 1 squared is 1 and simplify that into just that. So the next step here is telling us that we're going to use the equivalent values of x and y and replace them within this equation. Yes?
So what's the difference between so the cotangent and tangent? So cotangent you flip those, right?
Right.
So would there be a difference like 1 divided by y 1 over the regular? That's the same thing.
Oh yeah, no, those are the same. Yeah. Okay, so if I replace the x squared with the cosine squared, we would have a cosine squared of x, and if I replace the sine with y, we would have the sine of squared of x. Whoops. And that's going to equal 1 squared, which I hope you all agree is still 1.
Okay.
Okay, so do you notice the way that I wrote this, by the way? Yeah? Oh, that's okay. Did anybody happen to have written cosine like this when you were doing this on your own?
Yes.
Because you probably didn't know the actual notation, okay? So just so you know, this is exactly the same as this. These two things are equivalent. Okay, the calculator, if you're using it, you have to type it in as the cosine of x in parentheses and then square it. It recognizes this notation, but this is like the correct notation that you're supposed to write it on paper. Okay, why they throw the squared up here after the cosine, I got no idea. The math god made a decision one day, and that's what he decided. So we have to play it that way. So the first thing that I would do is, if I were you, I would put this piece into my notes. Okay, so this is called a Pythagorean identity. Okay, and this is going to be the first Pythagorean identity that we're going to write down. You do? Okay, so did anybody happen to do question 1, question 2, and question 3? What did you happen to notice on those 3 questions?
They're all 1.
They all equal 1. Okay, so the point behind question 1, question 2, and question 3 is it doesn't matter what value we put in for the angle, the identity is going to hold true. If you have cosine of any value squared plus the sine of any value squared, it will always equal 1. Okay, all right. So the next part of this, and I'm actually going to write this off to the side because I feel like I have a little bit more space. Okay, so it says, re-record your Pythagorean identity. Okay, so the Pythagorean identity that we found up above was sine squared plus the cosine squared is equal to 1, right? Okay, well, the first thing that this says here is divide every term, oops, I meant to highlight that. Divide every term by cosine squared. And notice that it says both sides of the equation. What I'm going to do is I'm going to divide every piece, okay, by cosine squared. Okay. So, manipulating this just slightly, if I divide everything by the cosine of 1 and simplify, we will get something new. Okay, can anybody tell me what sine squared over cosine squared becomes? Okay, good. So do you guys remember in one of the previous lessons, I don't remember exactly which one, it might have been like, I don't know which one it was. Anyways, we said that tangent is equal to sine over cosine. Do you remember that? Here, I'll write it down. If I can write remember. Tangent is equal to sine over cosine. You're going to have to write this down eventually, so if you want to write it down now, go for it. Okay, so if tangent is sine over cosine, then what is sine squared over cosine squared? Tangent squared. Okay, so this first term simplifies into tangent squared. Okay, the second term, we have cosine squared over cosine squared. What would that reduce to? 1. Because it's the same over the same, right? Okay, what about 1 over cosine squared? What would that become? What trig identity is the reciprocal of cosine? Secant. Okay, so it would be secant squared of x. Okay, this is the second Pythagorean identity. So write that down in your notes. Okay. Now the third piece of this, can I go ahead and slide? I will return. Okay, the second part says, again, rewrite our Pythagorean identity. Okay, so it was the original one we found, sine squared plus the cosine squared is equal to 1. And this time we're going to divide by the sine squared. Okay, so same exact idea as what I just did, but this time, whoops, divide by sine squared. So sine squared, and sine squared. Okay, my first term, I have sine squared over sine squared. What does that reduce to?
1.
Oh, sine, sorry. I'm thinking of the other one.
Okay, 1 plus. Okay, now cosine over sine becomes cotangent. So it'll be cotangent squared. There we go. And then 1 over sine squared, that's a reciprocal identity, is cosecant. Which, voila, gives us our third Pythagorean identity. Fancy footwork, huh? Okay. Can I slide over? Already have that down? Okay. So the next page says, basically what we're going to do is take each of our, well, not each of them, how many is that? 4 of them, and we're going to rewrite them by using sine and cosine. Okay, so we're going to write them in terms of sine or cosine, or maybe both. Can anybody tell me what cosecant is the same as in terms of sine and or cosine? It is what? 1 over sine. Very good. Write this down in your notes. You want this. Cosecant is the same as 1 over sine. What is secant the same as? 1 over cosine. Good. What is tangent the same as? Sine over cosine. So I did say this earlier. It's up to you if you want to write it again. It is incredibly important, so if you feel like you want to write it twice, that's good. Okay, what about cotangent? What's that the same as? Good. Cosine over sine. Okay, so these are super awesome identities. I'm going to star them and put a smiley face. All right, so why do we care?
Exactly.
That's a very good question.
That's a great question.
Well, because we're going to have some fun. Whoops.
I don't like those words.
You don't like fun?
Not when it comes to
It
math.
says we're going to have fun.
You know you're never gonna have fun when the paper says less.
Yeah.
Never fun.
You might be surprised. All right, so what we're going to do is we're going to take this, this sentence and we're going to prove that one sentence is equivalent to another. Okay? So we are going to convert the sine of x times the cosine of x into cosine. Okay, so what I'm going to do is I'm actually going to write this over here because I feel like then I have more space. So this is question number 1. The sine of x times, what was it? Cotangent. Yep. So this is an example of what you're doing. Okay, so I'm going to prove to you using Pythagorean, or not Pythagorean, using all of the identities, or not all of the identities, some of the identities. I'm going to prove to you that the sine times the cotangent is exactly the same as the cosine. Okay. So what I'm going to do is I'm going to manipulate one side.
English not working?
What?
So the same way you
English not working today?
Oh, sort of. It is kind of working. Okay, so I'm going to start by working with the left-hand side. Okay, it is usually easier to take more stuff and condense it into less stuff. Okay, so I'm going to choose the left-hand side to manipulate. Okay, so I have a sine and a cotangent. Can anybody give me an identity that I can replace the sine with or the cotangent with, knowing that I'm trying to get to a cosine? Can I somehow manipulate one of those? What do you think? Okay, good. Did everybody catch that? Cotangent is the same as cosine over sine. Okay, now if I have cosine over sine times sine, I don't know if you need to write this step, but I'm going to just to be incredibly clear. We can multiply these two fractions together, right? What happens at this point? Good. Everybody see how I have a sine on the top and a sine on the bottom? They cancel out, and what is left over? Cosine. So I have now proven that sine times cotangent is equal to cosine. Okay, so I am doing a proof behind an identity. Everybody follow that logic?
Sure.
You ready for another one? This one's way better. Actually, I'm going to do this one first because I like it better. I feel like it's a better lead. So I'm going to do question number 2 is, what was it? 1. Okay, so So here's my second proof. I'm going to show you that the left-hand side is equivalent to the right-hand side. Okay, so I'm going to manipulate the left-hand side because there's more stuff there. So if you see two quantities that are being multiplied, what is your instinct to do? To multiply them together. So if I'm multiplying two quantities, what do I have to do technically? How am I going to multiply these? I'm going to have to FOIL this. Okay, so to FOIL this, I have 1 times 1, which is 1. I have 1 times the negative sign of x, which is negative, whoops, a negative sign of x. I have a positive sign of x times 1, positive sign of x, and I have the sign of x times a negative sign of x. Good, negative sign squared, good. Okay, so now I would combine like terms. What do you notice about the middle two terms? They do cancel. So I have 1 minus sine squared. Okay, so does that kind of look familiar to you?
Just a little bit.
Like, what does it kind of look familiar to? The first identity, right? So the first identity that you wrote down looked like this, right? You see that one? Now check this out. If I manipulate this identity just a little bit, like solve for the cosine squared, and I subtract the sine over to the other side, I would have cosine squared will equal 1 minus sine squared. Interesting, right? Why is that interesting? What
Exactly the same.
is 1 minus sine squared equivalent to?
Just only applying for the hypothesis one.
No, it's an identity. So you're not working with a triangle. It's just we used a triangle to come up with these identities. Okay, so since 1 minus sine squared is equal to cosine squared, I have proven that these two statements are equivalent. How do we do on that? What's that? No one gets it?
Yeah, like what's the point of this? I don't
Oh,
know.
we're doing a proof
When would we actually use this?
today in class.
What is 1 minus sine squared x? Like how does that equal this?
Oh, so see how I took this Pythagorean identity and I just manipulated it a little bit? So I just solved for cosine. I can say that 1 minus cosine squared is equal to cosine squared by using this identity and then do that replacing. Okay. Okay, you ready for the third one? See if this is starting to trip. Okay, what's the third one? Does anybody have it there? So it's cosecant minus sine. That one's going to equal, whoa, cotangent times cosine. Do you think these two are equal to each other? I'll show you that they are. Okay, so I'm going to start on the left-hand side. I like to work with stuff that's being subtracted because I know that if I get a common denominator, I can combine it. So the first thing that I'm going to do is I'm going to rewrite cosecant using its reciprocal identity. Yes. On the right side, it's times. The right side is being multiplied. Okay, so what is cosecant the same as? Should I say that louder? Okay, there you go. So using its reciprocal identity, cosecant is 1 over sine. Everybody okay with me so far? Following? Okay. Now, do you see that I am subtracting fractions? Okay. What happens if I am subtracting fractions? What do I need? Common denominator. Okay, so if I'm working with the sine of x and 1, what is my common denominator? The sine of x. Okay, so this one is good to go. I need to multiply that right side by a sine of x. So I'm going to multiply by the sine of x times the sine of x. Okay, so I'm going to play this out in 2 steps just to be incredibly clear. It's up to you if you want to go to the second step. On my second fraction, I have sine times sine. What does my top become? Sine squared. So I have sine squared over sine. Okay, now once I have a common denominator, what do? Subtract the tops together. Okay, so on the top I now have 1 minus sine squared over my common denominator. Okay, so 1 minus sine squared, does that look familiar at all? Like maybe the identity we just used in the last question? So what is 1 minus sine squared equivalent to? Cosine squared. So I can replace 1 minus sine squared with cosine squared. Okay. Now, do you see the relationship between this one and this one? This is where I'm going to. How can I manipulate this?
Oh, because it's
To
one.
get
Because
that.
if you get cosine over 1 cosine over sine, then it's going to be a cotangent, and then you'll 1 cosine that.
Good. Okay, so what I'm going to do, whoops. Recording. Hold on. Okay, so what I'm going to do is I'm going to separate the cosines. Okay, so that's going to be the same as cosine times a cosine over sine. And cosine over sine is cotangent. So that becomes cosine times cotangent, which is, if you look back to the top, is that right side that we were trying to prove. Okay, I do have it in the opposite order, but does that matter? No. Okay, so that is a proof. How do you feel about this?
I feel like it's useless. I don't get it. I don't
Oh,
get.
this
why
is
we-
good critical thinking. If you can do this, you can do just about any kind of math.
I don't get why we need it.
This is good. Do notice in the directions that it says we're going to simplify it into a single trig function. Okay, so that's one of your 6 trig functions. It's all going to be simplified down to one single thing or one term. Okay, or a number, it says. Yes. Okay, so question number 1. Okay, the first thing that I'm going to do is I'm going to use my identities to somehow rewrite maybe the secant, maybe the sine, maybe both of them. So does anybody see where we could potentially go with this?
No.
What's that, Tyler? Okay, I think you're one step ahead of us. Where did you get cosine from? Does anybody know where we can get a cosine from? Yeah.
Yeah, because it's 1
So
over
see how secant is the same as 1 over cosine? Okay, here's my first step. I'm going to take the secant, I'm going to rewrite it. So this is 1 over cosine.
Kid got that far.
Okay, now if I'm multiplying 2 fractions together, I can multiply the tops together and the bottoms. Okay, now this might not be a necessary step for you, but I want you to see what I mean by this. Okay, so this is just going to become sine over cosine, right? What is sine over cosine? It is literally tangent. Okay, we have simplified this into one single trig function.
Oh, I was trying to
Oh,
complicate
but I
that
understand
way.
the equal anything or just
Right.
that was only calculated.
So the only difference between this worksheet and the problems we just did is that we knew what it was going to simplify into.
Oh,
This
okay.
time we don't know.
Well, that's okay. That makes a lot of sense. Okay, cool.
Okay?
Can we just write X instead of theta?
I would be okay with that. Yeah. I want to do number 7 with you. Okay, because I think if you can do number 7, then you should be good with the rest of these. Okay, now I will tell you that there is more than one way to go about simplifying these. Just because I see it this way doesn't mean that that's the only way that we can go about doing this. There's definitely multiple paths. So, does anybody see a possibility for us to convert one of these functions? What would you potentially do on this? What could you do?
Tangents. I don't know how you would do the sign unless you want to do sign or whatever.
Okay, let me give you a quick hint. So when you're working with things that are added and subtracting, okay, like so, we want to have fractions. Like that is a good thing because we can combine fractions by adding and subtracting, getting a common denominator, and that will turn it into one term. Okay, so we actually kind of like the fraction. That actually helps us get a little bit further. Okay, so how could I manipulate the sine squared or possibly the tangent squared? Okay, wait, say it one more time.
So the 1 over tangent squared
Yeah.
would be tangent squared,
Yeah.
which could change to cosine squared.
Ooh. Yes. Okay, so do you guys see how 1 over tangent squared is cotangent squared, right? Using its reciprocal. Okay, so cotangent squared. Okay, so, whoops, not cosine, my bad. Wrote the wrong one, cotangent. Okay, so now using the cotangent identity with a sine and a cosine, what is cotangent the same as? Cosine over sine. So cotangent squared is cosine squared over sine squared. Okay, so now I look at this and say, hey, we got two fractions that are being subtracted. What do you need in order to subtract two fractions? A common denominator. So do I have a common denominator? Yeah. Okay, so that means I can go ahead and just subtract the tops. So on the top I would have 1 minus cosine squared over my sine squared. Okay, now what do you see?
1 minus cosine squared.
Okay, good. So how can I say that 1 minus cosine squared is equal to sine squared? What identity tells us that? The very first one. So the number 1 rule of the Pythagorean identity, if we manipulate that just slightly, we can say that 1 minus cosine squared is equal to sine squared. I'm almost done here. What happens if I have sine squared over sine squared? It is equal to 1. So this one reduces to the value of 1. Okay. So I'm going to bow out at this point. I'm going to let you use your brain.